Today I'm here with my topic, that is occurrence of elements. Let me tell you about the elements. As we all know, there are 118 elements, in which elements are classified into three, that is metal, metalloids and non-metals, in which metals are of 92 types, metalloids 8 and non-metals 18, in which metals are classified into two states, that is free and combined state. In free state, these are non-reactive, and in combined state these are reactive. Some examples for the free state is Au, Ag and Hg, and for combined state it is NaMgAlCaKFeCuCO. And let me tell you about the occurrence of the element, that these occurs in means three state, that is first of all in earth crust these are metals, and atmosphere these are non-metals, and then earth earth's crust, that means innermost, then there is metalloids. And after that, let me tell you now about the occurrence of elements. Occurrence of elements are of four types, that is of biosphere, atmosphere, hydrosphere, lithosphere, and these occur in the different state. Like biosphere means normal environment, atmosphere means gaseous state, means in the gaseous form. Then next is hydrosphere, which means in water, and last is lithosphere, that means in the earth crust. Now let me tell you about the biosphere. In biosphere, the vitamins, it consists of vitamins, proteins, fats like DNA and RNA, in which iron means which is present in hemoglobin, then zinc means which is present in the Zn means eyes of the animals, then Mg means magnesium, which is present means which is present in the plants, like in the leaf, like chlorophyll. Then after that, calcium and phosphorus, which is present in the bones and the teeth, and MnCuFe are present in the chlorophyll, and I is present in the sea water. And by this we got to know about these all elements which are present in our biosphere. Now next is the turn for the atmosphere. In atmosphere, the elements are present in the gaseous state, like nitrogen is 78%, oxygen 21%, and other gases 1%, like Ar, Kr, Ke, Rn, and CO2He. And now next is the turn for the lithosphere. Lithosphere, which is present on the earth crust, like soil, oxygen, in which the oxygen, like non-metal, which is 46.6, which is present in 46.6%, and metals like silicon, that is 27.7%, and last is which is metal like aluminium, which is present in 8.3%. Next is hydrosphere. About hydrosphere, it is present in the 80% of the earth's surface, is covered with water, and elements like Na, K, Mg, Ca, Sr, Cl, Bri are dissolved in seawater. Now let me tell you with the help of the diagram, in which this all is the biosphere, in which it is present in atmosphere, lithosphere and hydrosphere. Hydrosphere means in water, atmosphere in air, and lithosphere means on earth, as we got to know by this. Like in atmosphere there are 97% of nitrogen, 21% of oxygen, and 1% of other gases. And lithosphere in lithosphere, oxygen is present only 46.6%, silicon is 27.7%, and aluminium is 8.3%. And next is about the hydrosphere. In hydrosphere, 80% of the earth surface is covered with water. And last is the whole biosphere. As we know, it is present in our vitamins, minerals, protein, etc. By this I am finished with my topic. Thank you.
Lovely evening, everyone. Today I am here to share with you chapter 6, that is general principles and processes of isolation of elements. So let's begin. So in this chapter we will directly come to our today's topic, that is extraction of iron. So here the question arises, what is iron? So as we know, iron is an element belonging to D block of modern periodic table. Also we know that iron is the most widely spread element on the earth crust. Also, it is very reactive element and is very inexpensive, means it's very cheap in rate. In everyday life, we come across numerous objects which are made up of iron, like bridges, keys, etc. So at the end of this module, we will be able to learn about the process of extraction of ore, and we will be able to describe the various parts of blast furnace. So let's start. Extraction of ore. Among metals, iron is the second abundant element on the earth crust. The most important ores of iron are hematite or red ore of iron, limonite or brown ore of iron, magnetite and siderite. Iron is generally extracted from its oxide ore. The ores generally have 20 to 55% of iron. Have you ever wondered that how the extraction of ore is done? So, extraction of ore is done by the following processes: calcination, roasting, smelting, and blast furnace. So, in calcination and roasting, ore is powdered and mixed with some coal and heated strongly in a shallow furnace. By this process, moisture of iron is removed, organic matter is oxidized, sulfur and arsenic impurities are removed as volatile oxides. The ore becomes porous so that the reactions become easier. In smelting process, the calcined and roasted ore is mixed with limestone and coke in the ratio of 8:1:4 and are introduced into a blast furnace. So this is the picture of blast furnace. In this video, we will look at the different parts of the furnace. So, blast furnace is a furnace that is used to extract metal from its compound using a suitable reducing agent. So, blast furnace is a tall chimney-like structure about 30 to 40 meter long and 10 meter wide at the base and narrow at the top. So, the bottom portion of the blast furnace is known as hearth. It has 3 outlets. One outlet is present on the top and 2 outlets are present at the bottom of the blast furnace. One outlet at the top discharge hot waste and 2 outlets at the bottom are used to discharge slag and molten metal. Gas discharge is further passed through dust catcher. This is dust catcher to remove the suspended particles and then fed to the stoves. These are the stoves to heat the air that is blown into furnace. At the bottom of the furnace are 2 nozzles called triers through which hot air is blown into the furnace. So this process is known as blasting, and that is the reason the furnace is known as blast furnace. Now, before ore is gone into the furnace, it has to go under concentration or pressing, roasting or calcination. When iron is extracted from the earth crust, it contains impurities like sand, rocky materials and limestone. These all impurities are further known as gangue. The impurities must be removed before the extraction of element. So the process by which impurities are removed from ores is known as concentration. The ore is then crushed into a small pieces in a crusher, and then the crushed ore is powdered in a grinder or pulverizer. Then the crushed powder is washed under the water. Here the heavier ore particles settle down, whereas the lighter impurities wash away with the water. The organic ore is now subjected to a process known as calcination. In calcination process, Besides converting the non-oxides compound in the ore to the oxide, roasting helps in removing moisture and organic matter. Impurities such as carbon and sulfur are converted to their volatile oxides which escapes. In addition, ferrous oxide present in the ore is oxidized to ferrous oxide. Now we will study how iron is extracted from the roasted iron ore. So the process of extraction of ore from its ore is known as smelting. In this, coal acts as fuel, which is further converted into carbon monoxide and is required for reduction of ore, whereas limestone acts as flux. What is flux? Flux is chemical substance combining impurities and form slag. The charges are brought by skip cars and are passed to the blast furnace. A blast of hot air is blown into tiers at the base of furnace, and this is known as blast furnace. Thank you and have a nice day.